Okay, good morning, everyone. I welcome you to another episode on probability graphical models. This morning, Prof will not be around, and he has asked myself and my colleague, Miss Connie, to facilitate this class on his behalf. So we start right away. So I welcome you all to today's class. And in our last class, we discussed on chain rule, the aspect of chain rule, which is a principle in probability theory that allows you to calculate the joint probability of multiple events by decomposing into a product of marginal and conditional probabilities. Take for example, suppose you want to know the probability of three variables x1, x2, and x3 all happen at the same time. Then the chain rule tells us that the joint probability of x1, x2, x3 equals the probability of x1 multiplied by the probability of x2 given x1 multiplied by the probability of x3 given x1 and x2. Yes, Mr. Damola, your hand is up. Let's go ahead.
Sorry, but we can't see your screen.
Yes, I have not started sharing my
Share
screen.
this.
I'll do
All
that.
right. All right.
Thank you very much. So let me share my whiteboard now. Okay, so we were saying that chain rules helps you to break down joint probability into products of marginal and conditional probability. But in PGM, this rule is simplified by using the graph structure to determine the joint probability of a graph or of a distribution. Like I mentioned earlier, let's say we have x1, x2, and x3. And we have a graphical structure, say x1, x2, and x3. So the joint probability of this graph now will be probability of x1, x2, x3 will be equals. Remember, these are edges and they show the direction of dependencies among the variables. The arrows, they matters a lot. This is a parent node because it has no dependencies. We call it parent node. All these variables, x1, x2, and x3, they are called nodes. But the x1 here is the parent node, and the lines here are the edges. Now, the joint probability of these three variables now, the parent node first. Remember, we discussed this in previous classes. That's the probability of x1 multiplied by the probability of x2 given x1 multiplied by the probability of x3 given x1. And with this, it helps us to reduce the complexity of using the chain rule and also to factorize the joint probability distribution into smaller pieces. Now, in today's class, we are going into conditional independence. Conditional independence. But before then, we need to quickly remind ourselves of conditional probability. What do we mean by conditional probability? We've done this in the previous classes. So conditional probability is notationally, let's say we have two events, A and B. Then the conditional probability is the probability that one event A, I'm denoting events here with letters, given another event B. This is how you represent the conditional probability. And mathematically, this is equals to, this is in our, you see this in our course manual. If you check the previous classes we have done. Probability of A, comma, B, all over probability of B. So this is the mathematical formula for conditional probability. And quickly, let's also remind ourselves of what it means for two variables to be independent. When we talk about independent variable, take for example the same event A and B. Then events A and B are said to be independent if the knowledge of occurrence of event A does not in any way affect the occurrence of event B. Please let me know if you have any question or any clarification so that I can go back with it. So in this case, if we say the probability of, say my focus for, is event A and B, then if A and B are independent, the probability of A given B will then be probability of A. Yes. So why? Because we already said if the occurrence of event A does not affect in any way the occurrence of event B, then the first occurrence does not affect the second. That's when the independent variables occur. In this case, whether event A or event B has already occurred, we have a piece of information on the occurrence of event B, but it doesn't affect the occurrence of event B. Then we disregard this. Then the probability of A given B will then be probability of A. Remember, this happens only when A and B are independent. Now, another way of expressing this is in terms of joint distribution. And let's say the joint probability of A and B. That's probability of A and or intersection B for independent events. In this case, independent events, remember, will be probability of A multiplied by probability of B. That is the product of their marginal probabilities. Is that clear, please? Please, do you understand?
Yes, ma'am.
All right. So let's move on to what we are talking about today, which is conditional independence. When we are talking about conditional independence, then it has to be conditioned on something. So for that purpose, I'll introduce another event, C. Now I have three events, A, B, and C. So let's start by defining the definition and the conditional event independence itself. Two events, A and B. This definition is in our course manner already. Two events A and B are said to be conditionally independent, given a third event C. If once we know the value of C or we have a piece of information of B, then knowing B gives us no additional information about A. In other words, A and B are said to be conditionally independent given event C. That is notationally by using notations, this is how we are right. A and B are conditionally independent. This symbol stands for conditional independent, the upside down T symbol, given event C. If the occurrence of A or the occurrence of B does not in any way affect the conditional probability of either A or B given C. And notationally, this is when we say A and B are conditionally independent given C. Now let's look at the Bayesian network, a graphical network of these three events. Say I have a network of any place of I say I have event A, event A, B, and we are conditioning these two events on C. Remember, this is an example of a directed graph, which we have discussed in the previous classes. All right, so in this case, what is the joint probability of ABC from this graphical network? And who wants to help us with that? Probability of A, comma B, comma C equals what? Anybody? Anyone? The joint probability of ABC. Okay, please go ahead.
So it now be probability of A, comma B, comma C equals to probability of A multiplied by probability of B given A multiplied by probability of
No. No.
Okay, ma. I just want to
That's
check like this, ma. I think it should be
Okay.
probability of A given that C has occurred multiplied by probability of B given that C has occurred.
probability of A
Given that
given
C has occurred,
multiplied by okay.
then multiplied by probability of B given that C has occurred. Yes.
Half correct.
But
So anyone else wants to try? Gabriel, you are right by saying P of A given C multiplied by P of B given C,
given
but that's not all. That's not all.
then divided by probability of C.
No, there's no division in this case. We are talking about joint probability. Anyone else wants to try? Who else wants to try?
Okay.
Okay, please go ahead.
Hello. Okay. Are you referring to the graph above, right?
Yes, I think
The
Gabriel
parent,
and
okay. Probability of C
probability of C.
multiplied by probability of yes, multiplied by probability of A given C.
A given C. Yes,
And multiplied by the probability of B given C.
excellent. Thank you. Gabriel, your hand is up. I guess you are supporting this new answer.
Yes, ma'am. Yes, ma'am.
Yeah, excellent. So thank you very much. And that's Mr. Ade Damala. All right. So when we want to determine the joint probability of a network, you start with the parent node, which is C in this case, as the probability of C. Remember, the arrangement does not really matter, but to make it easy, the probability of C first. Then the usual nodes, we call them child nodes, which is A and B. Why? Because they are dependent. So the next is multiplied by probability of A given C, then multiplied by probability of B given C. And Mr. Timothy, is that clear? Please kindly mute yourself. One is yeah, thank you. So Mr. Yeleye Timothy, is this clear now?
Yes, ma'am.
Thank you. So with this now, we have derived the joint probability of this distribution. Now, if we condition this on C, like I said earlier, the A and B, if A and B are conditionally independent, given C, then what do we have? That is probability of A and B given C equals, remember our formula for conditional probability earlier. I said the probability of A given B equals probability of A comma B all over probability of B. In this case, probability of A and B given C is also equals probability of A comma B comma C all divided by probability of what?
C.
C. Thank you. So this is the conditional probability in this case. Now, let's substitute this equation that we have here, call it equation 1, and we call this equation 2. Note that this disregard the small and the capital letter. They are all the same thing. But in your own case, you stick to 1. And it's for the purpose of writing fast because I'm using the mouse. Thank you. So probability of A comma B comma C here. Let's equate it to probability of A comma B comma C here. Then if you do that, probability of C, we cancel out probability of C. then you'll be left with this probability of A, comma B, given C equals probability of A given C multiplied by probability of B given C. Is it clear up to this stage?
Yes,
I
ma'am.
need a few minutes to respond. Okay,
Yes, ma'am.
thank you. Thank you. So in this case, we say that the probability, if this happens, then the A and B are conditionally independent given C. Then the condition that A and B are conditionally independent given C is satisfied in this case. So if A and B are conditionally independent given C, then the probability of A and B given C will be equals probability of A given C multiplied by the probability of B given C. Now let's look at the real world illustration in this case. Back to our course manual, we have an example. Let's say event A says that it is cloudy. Cloudy, remember? Okay. Let's represent cloudy by CL. And event B says the sprinkler is on. Denote that with S. Then event C says that the grass is wet. Now we denote that with G. So what does this really tell us? If we already know that the grass is wet, right, then knowing that it is cloudy, which is this, does not really affect. Remember, this is C, A, to make it more understandable, B. Remember, our probability here is probability that of A given C. That's probability that it is cloudy. When we already know that the grass is wet, probability that it is cloudy, given the grass is already wet, right? Multiply, we are substituting this in this case. Multiply that the probability that B given C, that's the probability that the sprinkler is on, given that the grass is wet. So if we already know that the grass is wet, then knowing that it is cloudy will not affect the probability whether the sprinkler is on or not. I don't know if you get that. That is, even though cloudy and sprinkler might be related, right? When it's cloudy, you think that it's about to rain, whereby when it rains, the grass will be wet. Also, when you use the sprinkler, the grass will also be wet. So these two are related. But if we already know that the grass is wet, then knowing whether the sprinkler is on tells us nothing about the cloudiness. Exactly. That's the probability that it is cloudy given that the sprinkler is on. Probability that it is cloudy and the sprinkler is on given that the grass is wet. All we are saying is that if the grass is wet, it tells us no information on being cloudy, whether the sprinkler is on or not. This is, let me just put the joint probability here. As the probability of being cloudy, and the sprinkler is on, given that the grass is wet. We already know the grass is wet, right? But it tells us nothing about the cloudiness, whether we already know the sprinkler is on or not. So that's that about conditional probability. Now let's move to the properties of conditional probabilities. Back to the course manual now. The first one here is symmetry. What does it? I think by now we are familiar with the property of being symmetry. That is, the order doesn't really matter. If the first one says if the probability of if A and B are conditionally independent given C, then B and A are also conditionally independent given C. That's on page 12. How many of us have with the course manual here? If you don't have the course manual, just type no in the chat box. No. Okay, I assume all of us has the course manual. It's important that you get the course manual, because even beyond your coursework in the university, you might still need to refer to it again. You might still need it for your industrial practices and all of that. It will be very useful afterwards. So we are referring to the course manual now. That's on page 22. And the second property here is the decomposition property. That means that if A and B are conditionally independent, if A is conditionally independent on both events B and D, now they've introduced another event D given C. This also implies that A and B are conditionally independent given C, and at the same time, A and D are also conditionally independent given C. That's the decomposition properties. That means if you have event A, which is conditionally independent on another event, B and D, given C at the same time, then event A will be conditionally independent on B, given C. And also event A will be conditionally independent on D, given C. In this case, independence from a group implies independence from each of the events. Now, the third property is the contraction property. This says that if A is independent on B, is conditionally independent of B, or if A and B are conditionally independent given an event C, and also A and D are conditionally independent given events B and C, then A and B, A is conditionally independent on B and D given C. In that case, we put the events together in two ways. The independence still holds. Then the intersection property, this is strictly for positive distribution. If A is conditionally independent on B, given two events C and D, and A is conditionally independent on D, given two independent C and B, then we are saying that A and B are conditional. A is conditionally independent on B and D, given event C. Please be sure to study this on your own after this class. So the next subtopic we'll be discussing will be on graphical representations of dependencies among variables. And I will leave that for only to take over from here. Thank you, Ms. Anya. Are you there?
Yes, good morning, everyone, once again. Okay, so do we have any questions so far on what Mrs. Kafaya taken notes?
No, ma.
Okay, all right, thank you. Okay, so today we are going to continue with graphical representations of dependencies. And if we have our course manual, please let's study the manual together. Mrs. Kavaya, you can stop sharing your screen. Okay. So first of all, I think we have talked about that one in the class, the difference between a directed graph and undirected graphs. So I would want one person to just talk about the way a directed graph looks like and the way an undirected graph will look like. Anybody? Okay. So it means I'm to assume that we do not know. So when we talk about a directed graph, when we have something like maybe x1 as a node, then somewhere here maybe we have x2, then maybe here we have x3, then we have the edges, maybe something like this. Something like this, it could be the other way. This is a directed graph because it shows the flow of influence, and you can determine which is the parent, which is the child in this kind of graph. So that makes it a directed graph. As you can see, it has edges. But when you have your graph and there are no edges, the arrow has no edge, and the arrow has no edge, and you have something like this, and you have something like this. So this is undirected. It only shows that there is a relationship between them, but you might not really be able to determine which is causing which and which one is having effect on which. You can only just know that yes, there is some sort of relationship existing between them. So we need to first understand those two types of graphs. We need to first understand that. Then the next concept that we have to understand is what we call this separation. This separation is is the short form of directional separation. You can even also call it dissep. So we just try and understand the concepts. We have the disseparation concept that I would want us to understand. We have the path. We have blocking as well. I think those are the three main concepts in today's class, and once we are able to get them and understand them, then I'm sure our job is done for today. We are good to go. Now, what is this separation? According to our manual, we have that this separation is a graphical rule used to determine whether two variables are conditionally independent given a set of other variables in the Bayesian network. So when I talk about Bayesian network, what should come to our mind is a directed graph. Directed graph. That is Bayesian network. So a graph that shows which is causing which. So when you're talking about your DCEP is supposed to tell you whether knowing a variable, a particular variable, will block the flow of influence or the path of influence between other variables. So that's the idea that we want to talk about. So under the DCEP, we are going to talk about paths and blocking. So we are going to be talking about paths. And then we have blocking. They are not word and opposites, but they are just two concepts that tend to come together. And blocking. All right. So what do we mean by a path? I would say that a path is any sequence of connected edges. Lead the direction, and regardless of the direction, any sequence of connected edges between two nodes in a graph is the path. So for example, when we have something like this, we have B, say we have C, so this is a path. You see this direction is like this. It could be the other way around. That's why I said regardless of the direction. It definitely has a direction, but regardless of that direction, any sequence of edges that are connected between two nodes is called a path. So I think we need to first understand that our material also said that a path between two variables is blocked. When we say blocking, it means that when they are conditionally independent. So it gives us two different situations that we can have. Fine, we have two different points in our materials, but the points are more like three different points. We have the chain point, we have the fork point, and then we have the collider. So there is the chain concept that we have to understand when we talk about paths. There is the fork, then there is the collider that we have to understand. Now, when do we have a chain path? When do we have a chain path? This path that I have right now is a chain path. And what does a chain path tells us? A chain path tells us that if this middle is known, if this middle, which is B, is known in our path, then the path is blocked. And what does that mean? It means that once you know your B, then A gives no extra information about C. So when you have any situation when you know a particular variable in the middle, you kind of have all that you need to know about the third one already because of the information you have about your B. Then that path is a chain path. That part is a chain part. And how do we write it? How do we write it? We would say that A is conditionally independent on C given B. And that means that our part is, like, we can say that B is blocking that part. Yes, let's put it that way. That B is blocking that part. Our material is blocked by conditioning on B. So this is how you will write this structure. I'm going to give us an example so that we can have a better understanding of it. So let's assume we have something like this. Maybe our A is wet ground. Okay, let's say our A is rain. Our B is wet ground, and our C is slippery ground. Our C is slippery ground. So in this situation of chain parts, let me draw that thing again. So we have A, then we have the B, which is our wet ground this time around. Then we have the C. Okay, so it means that originally rain is the parent node originally, because it is not conditional on another thing. So our A is the rain, then we have the B, which is the wet ground, and then we have the C, which is the slippery ground. Now, what is the chain part telling us? It's telling us that if we know our B, then we might not really need further information about our C, because we can predict our C based on the information that we know. So this B would have blocked the path that is supposed to flow from A to C. It would have blocked that path. So if we have the rain, and we know that there is a wet ground, then we might not really need to investigate if the ground is slippery, because knowing that the ground is wet will already kind of give us information that we need to know if it's going to be slippery or not. So once you know that there is a wet ground, that there is rain actually gives no extra information about slippery ground. Once you know that it's wet ground, it's like you already know all that you need to know about your C. You might not have to, investigate further. So that is what the chain is telling us. Then if we move to the fork, we have the direction is going to be like this. Don't forget that I already told us that regardless of the direction, once there is a connected edge between them, then between two nodes rather, then we can say that it is called a path. So if our direction this time around is like this, then we have the B, and then we have the C, okay. This path through is blocked if our B is known. That is why the chain and the fork are kind of categorized together, even in our material. You will see that it's there that a path contains a chain or a fork, and you have the direction. and the middle node B is in the conditioning set. So for either the chain, this is the chain, and this is the fork. So for either of it, B is a conditioning set. So once you know your B, you might not need to, your A will not give you extra information about your C. But this time around, once you know your B, then your A and C are dependent. But still, the B would have blocked the path. So if B is known, your path is blocked. Just like the chain, if B is known here also, your path is blocked. So I'm trying to think of an example. Okay, so let's assume that we have, maybe this time around we have, okay, let's have our A as temperature, our B as season, and then our C as maybe the kind of clothes that you wear, and the type of clothes, the type of clothing that you put on. Now, for this fork part, if we know the season, once we know the season, then the path is blocked. Once we know the season, then the path is blocked. We might not really need to investigate the type of clothes. You already have your temperature and you already have your season. Then the temperature it might not give you extra information about your clothes once you have known this kind of season that you have. I don't know if you are getting. So once you know the type of season that you are, your temperature might not give you extra information about the clothes because you already have your season. So, but if your season is not known, if it is not observed, then we can say that our temperature and our type of clothes are dependent on one another. See one another now, each other. So the temperature, your A will be dependent on C, or your A and C will be a dependent variable or node if your B is not known. But once your B is known, then the path is blocked and your A would not really give you extra information about your C. I know this might be a bit confusing. We might have to maybe rewatch the video and read further. That's why it's very, very important for us to have this material. Let me come again. Once your B is known, then your path is blocked. Your A will not give you extra information about your C. But if your B is not known, then your A and your C are going to be dependent on each other. They are going to be dependent on each other. That is for the fourth part. Then the third part, which is a collider, is when you have something like this. You have your node, then you have another node here. Sorry. Something like this. Then you have, this is C. Okay, so this will be a collider. This is how a collider will look like. Okay, so looking at a collider, normally the path is blocked. For a collider, the normal situation of a collider is that that path is blocked. However, as against these other two, once you observe this middle one, the B, then your path becomes active. That is the difference. The first two, the chain and the fork, once you observed your B, your path will be blocked. The first node will not give you extra information about the last node because of the conditioning. Is it conditioning set now? Yeah, conditioning set. But this time around, once you observe the middle, that's the B, the path becomes active. Initially, it is normally blocked. Observing the B makes your path become active. In our material here, we have that a path becomes a collider with that structure. Once you have something relating to that structure, then it is a collider. And neither B nor its descendants are in the conditioning set. So they are not the ones determining if the path is blocked. But once you observe them, then your path becomes active. That is the difference. So we have here that our A and C are independent. Also, A and C becomes dependent if we condition on B. If we condition on B, this time around, B is going to be called explaining away, not a conditioning set anymore. So A and C are independent. If they are independent, don't forget we have A is conditionally independent on C. A and C is independent. But if it's going to be a collider, we are going to have this symbol twice. With C given B. Now, a practical example of a collider is this. Let's assume we have our A to be rain, our B to be wet ground, like the example Mrs. Kafaya used, and then our C to be sprinkler. Okay, so the rain, once it rains, right, we are going to have a wet ground. If sprinkler is also on, we are going to also have a wet ground. So naturally, this part is blocked. But once we are able to observe B, then the path from A to C becomes active. And then they are conditionally independent. Your rain and your sprinkler being on will become conditionally independent once you are able to observe your B. That is the difference. Let me reiterate again. Your chain and your fork, once you observe your B, then the path becomes blocked. But in your collider, once you observe your B, your path becomes active. Is there any question? Do we have any question?
No, ma'am.
Okay. All right, thank you. So if we go to our 3.6 in our material, we have real world example. So that's just one more example to what we have discussed earlier. For the sake of those that do not have, we have A equals as flu, B equals as cough, C equals as fever. Okay. So this is a path. But what kind of path is this? Can we reason together? What kind of path is this? So let's assume we have A. We have A. I'm not going to put an arrow. We are the ones that will put arrows there by ourselves. Then we have B. Then we have C. Okay. So can we establish any relationship amongst these three nodes? Can we establish any relationship? We said we do not have any question. We said that. Okay, so probably let me just do this for us. Then maybe we'll do the other example. All right, so if our A is half flu, then we can have a path like this. And if you have flu, then you have tendency of having cough. But if we observe the cough, then if you have a cough, will having flu give us information about your fever once you know that you already have a cough? Will it? Anybody? Okay.
No, no.
Yes, I also think so. So I think we would have something like the rain, wet ground, and slippery road. So once we have the wet ground, we know that the road is likely to be slippery, since we knew that it had already rained. So if you have established that somebody has a flu and the person has a cough, we might not have to investigate further if the person has a fever. We already know that having that flu gives no extra information. We know that it's already a fever. So if this is the case, we will have something like A is conditionally dependent on C, given B. So that's okay. We know that flu is conditionally independent. Sorry, I was saying dependent, conditionally independent on fever, given that we've observed cough. So the explanation here is that knowing whether a person has a fever might make the cough irrelevant, whether diagnosing flu. Yes. Okay, so another one that we have is the aspect of linguistic and the POS tagging. So if we have a word and we have the tag. Then we have word to, and then we have another tag. Maybe a word is a noun, maybe cat being a noun, then sat, the cat sat on the mat, sat being a verb now. So in fact, let's put it down. So let's say cat. Cat being NN. Then sat. Sat. How do we write that verb? Is it VB or VR or something? Is verb written as VR or VB? Linguistic students. They are not in the class. Okay, VB. Okay, so this is word 2 and tag 2. This is word 1 and tag 1. So the example that we have here is that tag 2, which is verb, will be conditionally independent of word 1, which is cat. Which is cat. Yes, not really having anything to do with themselves. Which is cat, given noun. Yes. So once we've established that a cat is a noun, we know that verb and cat are conditionally independent. They are conditionally independent. So verb is not really giving extra information about cat, given that we already know that cat is a noun. Okay, another example that we have in our material here is student performance. Student performance. So we have A being study hours, B being exam score, and C being class attendance. So we have that exam score can be conditionally independent on study hours, given attendance. So if we have observed the attendance, then exam study hours might not really have anything to do according to this structure. You know, if you collect your data and all of that, then you can see something else. But based on this example, or how you will write it is that exam score is conditionally independent. That's the exam score. Okay, conditionally independent on attendance. Sorry, on study hours, given attendance. So one of the aim for today's class is for us to understand what the 3 part and blocking, what they mean. Also for us to know how to, write the symbols numerically, not just reading it as a note, but how to know when to write your conditional independence and all of that. And I think Mrs. Kapaya had already done justice to that. So we are rounding up today's class, but we have a R code here that we can run together. I don't know, Mrs. Kapaya, should I go ahead with the R code or you will take that? Hello?
Yes, please. Please go ahead.
Should I go ahead or you will take that?
Please go ahead.
Okay. Okay. So let me share my screen. Okay. So from the quotes that we have, we are going to, I'm just going to be typing them out now so you can also follow me. Okay, I can initially search here if I already have it installed. So I already have it installed. So I can just run. But if I do not have it installed, if you do not have it installed, you can just click on the install button here and type bnlane. So I already have it installed, so I can just run the library code. Okay, good. So I've been able to load the package. Then the next thing is net. Then we have model. So you can see it here. Model 2 network under bnlane package. 2 network. So we have yes, given A. And C. Okay, let me be sure that we're correct. Okay. Okay. Then you can now plot the network. Then you can have graphics. Plus the net. Okay, so we have so we have this. I want to believe that we can see this. So A is the parent node. This is why it's standing alone. Then we have B here, given A. B given A being the parent, B being the child. Then we have C given B. So if you want your node, if it is more than that, maybe you have D and is conditioned on C, you are going to have something like this. If you have your D conditioned on C, you have something like this. Oh, sorry. So can you see? And if it is conditioned on B, to give you another different structure. So this is a very short code for you to, practicalize and explore however you wish, so that you can get familiar with it. So you can see that this A is the parent node. Then you can see B given A here. Then you will see C given B and D given B. And that's why for C and D, B is a parent to C and D. However, A is a parent to B. And that's what you can have here. So quickly, let's answer few of the, in fact, it's even few, it's just five multiple choice questions. So let's quickly answer them and we'll round up for today. Let's quickly answer them. I want to believe that by now most of us should have the material. So I think I'll just call your name for each of the questions. Then you kind of explain to us why you are choosing your answer. I think we've always done that in this class before. Okay, so for question 1, For question 1, let's start with Oluwaseun Gabriel. Oluwaseun Gabriel, are you in the class? Hello? Okay, if Oluwaseun Gabriel is not in the class, how about Oyeleye Dupe? Oyeleye Dupe. What about Oyeleye Timothy? Are you avoiding answering the question? Is that it? Or you are really not in the class?
Sorry, I was talking, but I didn't know my microphone was mute.
Oh, sorry about that. So can you, I do have the material with you?
Yes, I do.
Okay, so can you help with question 1?
So for the question 1, it says in the network, as shown, which of these following is true? Like, I think the answer would be, I'm not sure. C.
Right. C.
Yes.
Okay, so
Like A and C are independent given B. Because like you explained earlier, that in A and C are conditionally independent. That means that if we know B, the relationship between A and C is no longer relevant.
yes. Okay. Okay, so I would agree with you. A and B being conditionally independent given C for that network. All right. Then question 2. Adeton or Adedoyin? Help us with question 2.
Yes, ma.
Do you have the material?
Yes, ma.
Question 2, please.
So, which structure makes two variables dependent when conditioned on the middle node? So, A, chain, B, fork, C, collider, and D, tree. I'm not sure, but I'll choose chain.
Okay, so can you explain?
The chain, when A, we have to have A, C is not necessary because once we know the condition for B, then
Okay.
I don't know how to explain, but I'll choose A.
Okay, I get what you're saying.
Right?
But if you check our material, check page 23. Towards the end of that page, you will see under collider, the second point, you see A and C become dependent if we condition on B or its descendant. So the answer should be collider. Which structure makes two variables dependent when conditioned on the middle node? Don't forget that we said that once we know the middle node, then that part becomes, the flow occurs, the part becomes active, then they can, if not, if they are going to be conditionally independent and then there is no flow, the part will be blocked.
Okay.
You understand now?
Okay. Yes, ma'am. Yes, ma'am. Thank
All
you.
right. So question 3. Ganiyat Afolabi. Ganiyat Afolabi, question 3. Help us. Ganiyat.
Yes, ma'am.
Okay. Are you with the material?
I'm trying to access the material.
Okay. Should we wait for you or is it going to take long?
Let's move on.
Sorry?
I'm still trying to check it. I'm sorry.
Okay. Mustafa Surajuddin. Mustafa Surajuddin. Mustafa.
I'm sorry, I'm not with the. Yes, I'm not with the material here, man.
Okay. Okay.
I'm sorry, I'm not with the material here.
Okay, that's fine. Mr. Adedamola Folabi.
Okay, question 3, right?
Yeah, question 3.
Still trying to assimilate this, but let me just try. Say what happens in a collider structure if the middle node is not conditioned on. I think variables are independent.
Can you explain why you're choosing that?
Because most times it's the middle node that really cause blocking, or maybe say whatever. But if it does not condition in any way, then maybe you have A, B, and C, and there's no obstruction, then the variables are independent. Like I said, I'm just trying to really go through it.
Okay. Yes, you are correct. You are correct. In a collider network, if your middle node, if it is observed, what did I say would happen? The path will become active, and they will be dependent. Your A and your C would then be dependent on one another because the path is active. But if it is reverse, if it's the reverse and it is not observed, or your middle node is not explained, then the path is blocked. Being blocked will direct you back to chain and fork. Once it is blocked, it means your A and your C are conditionally independent. So you are correct. Variables are independent if the middle node is not conditioned on. Then for question 4, who have I not called? Adelusi Toyin, have I called you? I don't think so. Adelusi Toyin, Adelusi, sorry.
No, I'm not. I don't have the material yet.
You don't have the material. Okay, please do well to get it. Oh, yeah, Timothy. Yeah, Mr. Timothy. Are you here?
Hello, ma'am. Yes, I'm here, ma'am. I'm very busy.
Yes, good morning, sir. Are you in the material?
Attend to them. So let me read the question and answer it. So in this separation, when is a path considered blocked? So I will choose the answer C, when certain structures are conditionally corrected.
Okay, can you explain why you're choosing that?
Actually, I did not follow the lecture throughout because I'm attending to some certain issue in my place of work. So I know that it's D, but it's A, is C. So what I can say is that when this separation is direct separation, so the graph determine whether the two variables are conditionally independence.
Okay. All right. Okay, so for that question, when is a path considered to be blocked? I've actually explained it. I talked about that if you have a conditioning set, that's in the terms of A, B, and C. Now maybe a B, and it depending on your arrow or your direction of relationship, then you can know if your path is blocked, knowing your B, or if knowing your B will make your path active. So I would also agree with you that when certain structures are conditioned correctly, then a path is likely to be blocked. When you are talking about the separation. Then the last question, who has not? Ganiya, have you been able to access your material now?
Yes, ma'am.
Okay. So can you help us with the fifth question?
Okay. What does this separation help determine? Conditional independence. That's what it helps us to determine.
Okay, do you want to explain for those that did not really follow the class?
Okay. It is a rule used in Bayesian network to determine conditional independence by checking the paths between variables. So it
You've just
is
read
used to
material.
determine. Ma?
Go ahead.
Okay, so it is used to determine if two variables are conditionally independent. So given other variables.
Okay, thank you very much. So the main idea of this C separation, the path blocking and all of that is to test for conditional independence. That's the main idea. That's the summary of today's lesson. All we are doing is, are they conditionally independent or not? Are the paths being blocked? If the paths are being blocked, how are the paths being blocked? Is it because we observe the B that makes the path being blocked, or because we do not observe it that is making our path to be blocked? Okay, so I think that is all for today's class. So I'm going to hand over to Mrs. Kafaya for announcement and to close the class. Mrs. Kafaya, you have the floor.
Yeah, thank you, Ms. On. So I think we posted on the group a few weeks back that if you'd be interested in having a physical tutorial class, you should indicate and with a convenient date for the two departments. But so far, the response is very low. So we want to confirm when your exam dates will be, and this will guide the tutorial moving forward. It's just a physical class to address if you have any challenges or you've been dealing with any difficulty in any of the courses we've taken so far. So I'll throw it out for the linguistic students first. When it's your exam, if perhaps you know when it will be.
Well, it's not determined yet, but next month, yes, our exam is going to be next month. Maybe early next month. Maybe the first 2 weeks or so.
Early next month.
Yes, but I'm not really sure.
Next month of
But I know
September.
it's next month. Yes, September, yes.
Okay.
All right. How about the statistics students?
Yes, ma. Same too with statistics. Yeah, same something around second week in September or something like that. That's what we heard yesterday or so.
In September.
Early next month.
Okay. Okay, so let's assume the exam will be happening around the same time then, in that case. So if you are going to fix a tutorial class, I need everyone's opinion on this. And for this tutorial to hold, we need to know where you want us to come in. Say we are fixing the class for tomorrow. What do you want us to do? Which part or which area do you want us to emphasize on for that physical tutorial? So I'll start with Adelu Sitoin. I think you are first on my list.
Um, Good morning, ma. So I wanted to ask, you said the tutorial is tomorrow.
I said, say the tutorial is tomorrow. Let's assume it's tomorrow.
Okay. For me, I don't. The topic that we did today
Don't
actually
have
is not
any.
really clear to me.
It's not really
Clear to me, like
okay.
and that's why
So
I'm
you
having
would
it
want us to,
go over
perhaps
it.
you would want us to take the topic.
Yes.
So is it today's topic alone, or there's any
Yes.
other? Okay.
Mm, Just the
Okay. So on my list here is the next one is Mr. Adidamala.
Ah, please, I will just want to go with other students, whatever they conclude. Please, I don't know. I would like to go with them.
Okay. Does that mean you have no issue either we hold the physical class or not?
No, no,
Perhaps you are indifferent.
I want it. No, no, no,
Oh,
I'm
you
not.
want
I
it?
want it,
Very good.
of course.
Very good. So
Especially
let's say we are
the
fixing the
the
class for tomorrow.
ah I well, I'm thinking maybe like this last topic now uh we just treated, and
Okay.
and maybe because like from the materials, I think the further we go, the you know I mean the topics ahead are a bit kind of complicated in a way. So I'll just want us maybe after having like 2 or 3 classes, then we can now take it up from this particular class. Then the application part of it, that is the R code and
Are you
the
saying that we
likes.
should suspend it in physical class for now?
Maybe after 1 or 2 classes, then we can now have physical class,
But
because
you
I
want
like that's my own view anyway.
okay. Yeah, but there's the exam is near already, and some students here are not doing just this course alone. You need to also study for other courses.
Sorry, Mrs.
Okay,
Papa.
in that case, maybe we can treat this class
What
and the
week of
next
lecture
class.
are you? What do you say? What week of lecture
Ma,
are you? What week of lecture are you? Because in my mind, I'm thinking like we are still in the 5th week. So exam coming up in the next 2, 3 weeks is surprising to me. What week of lecture? Anyone?
I think we should be around week 11 or 10 or so. As
Wow.
resumption, yes, because we had to like hold on until linguistic students when we were done with their exams before they now joined us, before we now started the whole 772. But before then, we've started other lectures like 4 weeks ago, like a month ago or so, before we started 772.
Okay, because I was just thinking that this class is like maybe the 5th or 6th time.
Hmm. Okay. So, Ganiat, what's your opinion on how the physical class should be? Okay, Ganiat said her network is bad. She was not following the conversation. Okay. Mustafa Surajuddin.
Well, as for me, the physical class, it is a nice idea, but for me, I'm okay with all the classes done so far, except for the one we did to this lecture, which is not that clear to me, or maybe because I've not gone through the but for today's lecture, I don't really understand it. So that is my take on it.
All right. And so next person is Oluwaseun. Oluwaseun Gabriel. So let's hear your own opinion.
Okay, me okay as at now. See, like for now, to just like when we are going to like fix the dates, like the time we should fix. That's just what is me. But I'm okay with the physical classes too. No problem. Thank you, ma.
Can you say that again?
I say I'm okay with the physical classes. That's just when we are just to fix the time, both linguistic and statistics. There should be a time that will be okay for both of us. But I'm okay with the physical classes.
Okay. So Gabriel, how many of you are in statistics?
I
Or
think it should be 7 to 8 in total.
7 to 8.
Yes.
But how many of you are here now?
And, okay. Okay, I can only see like 4 now.
Well,
Yes, ma.
does that include Mr. Adedamola and Mr. Ileye Timothy?
No, ma.
So who are those for? I want to.
Mustafa,
Okay.
Mr. Mustafa, then Adelusi Toyin,
Okay.
then Doing too. She just left now, but she too, she's still there.
Is
Adeton
he
and Toyin. Yes,
okay?
Adeton and Toyin. Yes.
And okay, and you?
Yes, ma.
Okay. All right. Oyeleye Dupe.
Okay, thank you. Actually, there is a need for a physical class. But I think what I don't know who spoke earlier, that maybe after some classes, because I think from today's lectures, many people, including me as well, we are getting it like not as easy as previous classes. So I said that maybe it's not getting harder. I don't want to use that word. So what he's saying is maybe the next classes too, because I'm sure like it's like a flow. So the next class will definitely depend on this last class. So maybe we should have the tutorial or the physical class maybe a week before exam or 2 weeks, where we've covered some other aspects that we're going to cover.
All right, that's noted. Mr. Oyeleye Timothy.
Hello, good morning, ma'am. I will
Yes, sir.
suggest that we should have the physical class. So we can have it in first week in October, in September rather.
September. All right. I think Mr. Adedamola and Oyeleye Dupe, they are supporting the motion that we should have it like 2 weeks before the exam. Around that time, perhaps.
Yes. So at least it will not just be this class alone that we'll be covering. Maybe it's in case we have other challenges. But I'm sure previous classes has been self-explanatory and okay for me. But I like actually today's class is somehow confusing in some aspects, and I don't know how the next class will also be like.
Okay. So, Mr. Adedamola, are you in support of that? 2 weeks before the exam.
Yes. Yes, I'm in
What about
support. But another thing,
okay?
another thing I don't know is the period for the linguistic exam. You know, it might not be the same time, so that's another factor we have to consider. But by and large, I think the appropriate time to have it is like maybe 2 weeks to the exam. That would be better, or even a week.
Okay. What about Seun? Oluwaseun Gabriel? Adetono or Adetoyin? I've not called you. Please go ahead.
Yes, ma'am. I have questions.
Okay, please go ahead.
Number one, I don't know the syllabus for the class.
Okay.
Like, number two, are we having any tests concerning this course? Then, today's class is kind of very confusing for me, so I need to go through it. But still, I still need like teaching on it. So I prefer, let's say, 2 weeks before the exam, because a week is kind of tricky. So that's the question I have. Answer.
Okay, so let me take it from the last one. The test for the exam that will be communicated going forward. And if by adventure, also I think you've been given some assignments on this course.
Yes.
Yeah, if you check the Google Classroom, please note that those assignments, we have an offline sheet for it where we grade how you attempt, who attempts, the way you attempt them, and the way you answer them. Yet it's not just about you attempting the assignment. It's also about you learning more on whatever we treat in class. And also how do you approach those assignments. Those are also important. And also your attendance in class. I really need to know those who have not been attending these classes since we started. For example, I think the linguistics students should be more than this. So is the statistics students. So please, all these are very important. And as for your test, how that will be graded, you will be communicated going forward. If necessary, we are going to communicate with Pro from that. Do you understand that?
Yes, ma'am. What about the syllabus?
Yeah, the syllabus. Yeah, the course manual. Do you have the course manual?
Yes, ma'am.
Yes. So the course manual is what we are using for this course. And Prof made mention of that earlier when we started this class. Said it's important that you get the course manual for the purpose or the sake of this class. And that's what we have been using. Any other extra material we have been using, we treat in class and then post in the Google Classroom afterwards. For example, the chain rule that was treated last class is an extension of this manual, though not extensively here, but it is now in the Google Classroom. Does that answer your question?
I mean, are we to cover the whole textbook, the whole manual for this
Yeah,
semester?
I will
Like,
throw it back to you. Do you think it's still possible for us to cover the whole manual?
it's not
Adebe?
possible.
No? How do you think? Why do you think it's not possible?
The manual is much. It's not possible for us to cover it, and this is just like 3 weeks to the exam.
Okay, so let's see what happens before the exam.
Okay, ma.
Yes. So I think your questions are answered now. Is whoever have I know? Who else have I not called? So is everybody in support of 2 weeks before the exams? If you have contrary opinion,
Yeah.
please. Okay, Ganiat, you say?
Yes, 2 weeks before exam is okay.
All right. So let's say the exam periods for the two departments are different. What do we do in that case?
Wait, sorry, please. I just have a question. Are we going to be writing different exams? Because my own
Well,
understanding is, irrespective of the number of departments taking a course, they are going to be writing that particular course together. I don't know if it's different in UI. So,
yes, I
and
understand.
another thing, please, is it possible we have like past questions? I don't know if it's right, if it's proper to ask like previous questions on this course. At least that will help us more to prepare better.
Let me take the first one.